Welcome to this hybrid event arranged by the IET's Angling Coastal Local Network, which represents members in Norfolk, Suffolk and North Essex. Welcome to those of you in the audience here at the atrium, and also to those of you joining via Teams virtually. I'm Kevin Foster, I chair the IET Angling Coastal Local Network, and I'll be your host for this evening. So without further ado, I'm delighted to introduce our speaker, Mark Power. Mark worked for a FTSE 100 company in the telecommunications industry for many years, and I'll leave you to guess which one that might be. And he developed and managed many mission-critical applications. He authored 3 patents for improving web-based application performance and developed a public Wi-Fi monitoring solution for the London 2012 Olympics. As head of software engineering excellence, he led the transformation of software engineering practices for a community of over 12,000 software engineers. Now at the University of Suffolk, Mark is a lecturer in computing, and he has been known to mention personal calculators just once or twice in his lectures. So Mark, over to you.
Thank you very much, Kevin. The talk tonight is called Calculators with No Equals. This is not a bit of bragging that this is the only company's calculators that are really, really good. The models I'm going to talk to you about are Hewlett-Packard ones. They're perhaps less well known than some of the other makes in this country. For example, Casio tends to dominate the market. It's a bit of a joke, and it was actually a joke used by Hewlett-Packard, because you'll notice this is their first ever pocket calculator over on the right-hand side. It literally has no equals key. So hence calculators with no equal. Many Hewlett-Packard calculators use a system called reverse Polish notation. Now, we refer to the acronym RPN. Now, prefix notation, which computer scientists amongst you may have heard of, was a notation formalized by Jan Łukasiewicz, so I can get it right, in the 1920s. He came up with Polish notation, and Hewlett-Packard adopted reverse Polish notation, which, if you're a computer scientist, this is postfix notation. And it avoids the needs for parentheses as well. So if you look on this keyboard that's shown here, on this HP 35, there are no parentheses keys, no brackets on there, as well as no equals key. So this is a bit like Yoda, we calculate. I've got a couple of calculators from another manufacturer, and I typed in the other day in what they describe as algebraic or infix notation, 2 + 3 × 4. And on one of the calculators, it came out with the answer 20, and on the other calculator, it came out with the answer 14. These were both by the same company, yeah? So if you're numerically challenged, that could be a bit of an issue. And we teach in schools nowadays, our children taught BODMAS. We come across this: brackets, order of power, division, multiplication, addition, and subtraction. And on some calculators, you'll see the brackets keys, and between them, engraved on the keyboard, will be something like there'll be a number, and it might be 6 or it might be 10 or something like that. That's been quite common, and that's the number of brackets or the number of automatic brackets that it might handle. But there's a bit of ambiguity there with is your calculator really following this notation or not? Is it giving you the right answer? And if you weren't aware of the magnitude of the answer, you might let 14 slip through when it meant 20 and vice versa without realizing it. So it's just something to be careful of. So reverse Polish notation or postfix notation uses this idea on the right-hand side. So to put in the same sum, I type in the numbers 2, I press the enter key, which is the big, massive one, double width one in the middle of the keyboard. So I put 2, enter, 3, enter, 4, and then I press multiply to multiply 3 by 4, and then I press plus in order to add the 2 to the result. Now you can see This is not immediately obvious, is it? As computer scientists, I like this. The reason I like this is because if you're a computer, you need to know before you perform an add instruction or a multiply instruction what the two parameters are going to be. Yeah. So this is logical in terms of how a computer works. So if your brain works like a computer, reverse Polish notation or postfix notation makes sense. Convincing the rest of the population that this is a good idea can be quite tricky. It does sort of make sense in some ways when you're really young and we're taught arithmetic and you do long addition and that sort of thing. You write the two numbers down and then you say, I'm going to add them together. But yeah, I think the jury is firmly on the side of we'll go with the slightly, well, the potentially ambiguous version. So operands are known in reverse Polish notation before the operation. All of the values are pushed onto a stack. Because memory was limited when the calculators first came out, that was in the early versions, some of the Hewlett-Packard original desktop calculator, it had 3 levels of stack. So you could only have 3 numbers that you were dealing with. They, as soon as they went onto the pocket calculators, they moved to 4 levels of stack, and it remained that throughout the entire reverse Polish notation period. The beauty of this is that you can, although not with multiply and addition, you can have functions which take multiple parameters, and you just keep shoving them on the stack, and then the operation will pop them all off the stack, perform the operation, and put any results back. So we're calculating like Yoda. The HP 35, which you've seen a picture of already, was the world's first pocket scientific calculator. It was advertised as the electronic slide rule. So for those of you who've never seen one before, I think all of us in the audience were probably taught on something like this. This unfortunately, I lost mine. This is my mum's, believe it or not. It's made out of a nice piece of wood. It says made in England on the front. It does basic log and trig functions, and it's got a whole pile of formula on the back. So the HP 35, which is shown here, was marketed as the electronic slide rule. That's how Hewlett-Packard marketed it in 1972. And it came about because Bill Hewlett asked for a pocket version of the HP 9100 desktop, which came out in 1968, which was an absolute beast of a machine. This calculator has log and trig functions. You'll notice perhaps it's got x to the power of y as one of the keys. It doesn't have a 10 to the power of x because they thought, well, we don't need that. You can just type in 10 and hit the button and it'll do the right thing for you. It only worked in degrees, which is interesting. The x to the y I mentioned, it was $400 when it was introduced. A couple of years later, when it was withdrawn, it had dropped in price to $195. The back, this is the metal plate, the middle of the slide here. This is the metal plate on the back of the calculator, and it shows you, it gives an example of how to use the 4-level stack. So down at the bottom here is the 4-level stack, and it shows how operations are performed on it. So that was the electronic slide rule. The following year, I don't own one of those, unfortunately. The following year, does that appear on the owl? Are we seeing that? I don't know. The HP 45 came out. This was actually HP's 3rd calculator. So in between the two was another model, which I don't own, which is the HP 80, which is a business model. And we'll talk about business models in a while. They'd done some tweaks to this one. And in particular, the x to the power of y became y to the power of x, and they're the levels of the stack, the bottom 2 levels of the stack. The display is the x register, the y is the one above it, the z's above that, and t is the top of the stack. They also added a last x, and there are lots more functions. So this has, down in the bottom corner, it has, you can see sigma plus, so it does statistics operations. It has degrees, radians, and gradians, which we sort of expect, although I don't think, has anybody ever used gradians? No, it's one of those you have. What do you use them for? Field things. Yeah. It has 9 memory registers, and you can do arithmetic with the memories. So you've perhaps seen a simpler calculator where you've got a M plus button and maybe an M minus button. On these, you've got 9 registers. You can store and multiply into any of the 9 registers, store and divide, store and subtract, store and so on. But you can also do recall divide by any of the registers as well, which is quite sophisticated. It's got, which is very strange, it's got a hidden feature. There's a certain combination of you press down a whole pile of keys, and there is a timer built in, stopwatch. But if you do it, and on this one, if you do it, it's horribly inaccurate. I was doing some research at the University of Cambridge recently, and I came across an advert for a company in Corvallis who would sell you a piezo crystal that you could take this apart, solder it onto the circuit board, and it made it super accurate. So it's a bit strange that they used all of that ROM to build in this timer function, then just didn't add the piezo function that would make it work. The HP 55, which came out later, had the crystal built in. What was interesting about this one, it was advertised as double the power. And I've given the game away with my final point here. The gold key in the top right-hand corner is a shift key. And that this was so revolutionary that Hewlett-Packard had to explain to the public. You know, bear in mind, a year ago we were using slide rules, and now having to explain that above a whole load of these keys, we've got conversion functions. We can convert between centimeters and inches. We've got converting into degrees, minutes, and seconds. We've got polar to rectangular conversions and all sorts of stuff like that. So it was advertised as double the amount of power. The following year, really massive change. So this is the HP 65, and this was advertised as the world's first handheld computer. And the reason for that is that whereas the 45 and the 35 were just scientific calculators in the traditional sense, this one was programmable. This one you could type in 100 lines of program memory, so more or less 100 bytes. I think for a modern computer scientist to think, what on earth can you do in 100 bytes? You know, give me 100 meg and I'll build you an application. But this ran with 100 bytes. This one works. It doesn't have continuous memory, so whatever you put into memory is lost as soon as you turn it off. Hopefully you can see this, but if I put in the card in here, it reads the card, and I didn't get an error or anything like that. So my 100-byte program has come off this little tiny weeny stick and has got my program. And there was a little slot in the side, so you could write on the card what the program did, and you could reassign the top 5 keys. So you slid the little card into the top above the keys, and then I've only got a little noddy program on here, and if I press this key, then you can see the calculator, hopefully, can you see that? Yes. Flashing away as it runs the program very slowly. Yeah. Oh, sorry, I've made a slight mistake. I'm talking about the 65, but this is a 67. That's fine. Anyway, you get the gist. So the 65 was the first one. Hewlett-Packard saw the potential with this, with having programmability, and so they brought out PACS, so spelled P-A-C-S, which seems to have lasted forever. And what you would get is you would get a pack of cards like this on different topics, and they would be the dark pre-programmed cards with a whole load of programs in there. And the PACS they sold a huge number of them. So everything from additional maths functions, electrical engineering, chemical engineering, stats, surveying, finance, navigation programs, medical programs, and an immense number of packs were sold for this calculator. The calculator itself was used on Apollo-Soyuz. If you think about it, computers at the time were pretty big, they're pretty heavy. The ones that were used on the Apollo missions for the moon were great big rack-mounted things with core memory and all the rest of it. Here you've got a personal programming device. Remember, this is a long time before laptops and PCs. 7 ounces, you can have programs in it. Your astronauts can carry it about and all that. The 65 led to the formation of the HP 65 users group. That was later renamed PPC. And in the UK, we had PPC UK, which we renamed HPCC. And that is our calculator club for handheld and portable computers. Maybe Hewlett-Packard Calculator Club, maybe, if you used an alternative, unofficial acronym. But that club was formed in 1982 and we're still meeting in 2024. So I'll tell you about that a bit later. The 20 series came out. Here's 3 models. They look very similar. They're slightly smaller than the other ones. There was a standard scientific model, a business model. We can see just about it's got number of periods, interest rate, payment, present value, and future value, which is sort of standard solver type things for business equations. And then the HP 25, which was the bottom end programmable, if you like, below the ones with the card reader, that introduced continuous memory. So now you've got the ability to store a program, to have a program remembered when you turn the calculator off. This is pretty revolutionary. It saved you having to type in your 50-byte program multiple times. You could turn it on and your 50-byte program would still be there, available for you to run. So quite crazy. The one I showed you by mistake earlier on, the HP 67. This was contemporary, if you saw the Texas Instruments ones of the time, with sort of TI 58s and 59s, those sorts of things. The TI 58 didn't have a card reader, the TI 59 did. So you've seen the card reader. These two, this is Big Brother, so desktop version. It has a printer built in and the magnetic card reader, and I can feed the same card in there. But I've lost it. And feed it into the front. It'll go in, hopefully. It liked it, and I can run my program, and off goes the same program, and that's running again on this one. So these two were software compatible with each other. More memory on this one, 224 program steps, 26 memories, the magnetic cards. They were software compatible with each other, more program packs and solution books as well. And they literally sort of went A to Z. So it was the astrology, antennas, anesthesia, immense number of programs available for these machines. Then HP went wild and wacky. This is not a reverse Polish notation calculator. It actually has an equals key somewhere in there. This potentially, is it the first smartwatch? It's a bit debatable. Smartish watch. I mean, it's not running apps or anything along those lines. It tells you the time. It's a calculator, a stopwatch, a timer. It has an alarm. You can see it has an LED display. So it absolutely ate its way through batteries, and the display was off all of the time until you press the button. Not dissimilar to earlier Apple watches, yeah. It allowed you on the calculator. You've got functions on there that allowed you to do date and time arithmetic, which is quite handy. And what was more bizarre was that it had this idea of dynamic calculations. So if you were rich enough to buy one of these, and they were pretty expensive, you could put in your hourly rate when you were out doing your consultancy and hit go, and you could see the pound signs ticking up on the display. Yeah. So, so not just the time ticking over, but the money that you were bringing in. It came out in 1977. It was very quickly superseded by much cheaper LCD watches, you know, the Casios and all of those sorts of things that we're familiar with. It was incredibly expensive at launch. You can buy one now, if your pockets are deep enough, working secondhand for about £3,500. So I don't have one of these, beyond my price range. So an interesting diversion. The HP 34, I talk about this. I said this at the start on the cover, that this was an abbreviated history, so I'm not talking about all of the machines. The HP 34 replaced the HP 25. It was the advanced scientific programmable, came out in 1979, still an LED display. It had continuous memory, so it remembered things when you turned them off, programs when you turned the calculator off. You could have 221 steps, 210 steps, or 20 memory registers, so you could tailor a bit from one to the other. What's interesting about this particular machine is down here at the bottom of the keyboard, you might just be able to see an integral symbol with X and Y, and then next to it a solve button. So previously, if I was using my HP 67 or something along those lines, I would program it with a route finder program, or I would program it with an integral program, you know, so Simpsons and Newton-Raphson and all of those, you remember all of those sorts of things. You would put those programs in and then you would give it a formula and off it would go. This was the first calculator to have those functions built in. And so all you had to do was type in the function that you were interested in solving the roots of, pass it to the solve function, and off it would go, and it would merrily go away and calculate for you and come out with the numerical value. So a first for that one. Now, 1979, the HP 41. Obvious things to start with, it's got an LCD display, and it's alphanumeric. When it came out, it had 12K of ROM and about 0.4K, 448 bytes or something like that of RAM. And this is what that looks like. This is one of the models. Unlike the Texas Instruments models, the high-end ones, this one's got 4 ports in the back, so you can plug. I'll pull the right one out. So you can plug in little memory modules. When it was launched, you could plug in four RAM modules that added about 0.5K each, so you could max the RAM out. They very quickly realized that if you did that, you filled up all of your ports with just RAM, and they wanted to sell you other stuff. When it came out, there was a printer available that you could plug in, and the other thing which was intriguing, it has no card reader. But there was such a massive amount of software available for the HP 67 and the HP 97 that what they did is they made a card reader an accessory. So even though this has got continuous memory, you literally plug the card reader in the top, feed your card in, and you can load your programs. And it provided software compatibility with all of the thousands of programs that had already been written. Another thing. Remember, these are the days before PCs, before laptops. If you had a computer around this sort of time, it wasn't terribly good. You know, late 1970s, it would have been pretty poor. There were other calculators around that time, beginning of the 80s, that had cassette interfaces, and you could record your programs on cassette. So some of the Casios had that facility. But there wasn't a really good way of distributing programs. And one of the other more interesting facilities that this calculator has is that you can plug in a barcode reader. So I plug my barcode reader in, turn it on, and what Hewlett-Packard used to sell and what our club magazine used to do is our programs, we printed them as barcodes inside the magazine. So rather than having to ship out a cassette every month, or how often it was, you plugged in your barcode reader, swiped backwards and forwards, and that put the program in, save you having to type it in. I mean, that's quite an unusual thing, isn't it? The beauty about this, of course, is that so long as you've got the hardware with the barcode reader and that, you're never going to get falling apart. You know, you're not going to find that your floppy disk no longer works. This is paper. We know this stuff lasts for hundreds of years, doesn't it? So it's quite a novel innovation on that one. So it was expandable. You could plug in the modules, you could plug in the magnetic card reader, the barcode reader. After a while, they brought out a time module and an extended functions module, which added loads of extra text type functions, and it added a RAM disk. So you've got a continuous RAM disk. So, and you could store textual data, numeric data, and programs inside the RAM disk. Don't get carried away. 6.4K max. Yeah, this is still pretty tiny. Later on, they brought out. I didn't bring it. They brought out a module which added infrared, because they produced a printer that you could talk to using infrared. But the real revolution with this, and this is where I mean, I love this calculator. It is it is my favourite calculator by a country mile, and the reason is this. So this is the HP interface loop. So you would plug this into a port on the back of the calculator, and then you had two wires, and you put them round in a loop, and onto that loop you could plug, admittedly, pretty expensive devices. So this is a digital tape drive. It uses little sort of dictation type cassettes, but these are digital. This is a digital medium. This is like using a big computer. Yeah, I can create a file. I can tell it how big I want the file to be created. I can save programs. I can do all sorts of stuff on this. It is, if we can get it to go. Oh, that's good. The battery decided to stop. Never mind. But it creates a directory structure, just like big tape drives did in the day on big computers. Yeah, only it's miniature. So you could hold hundreds of programs on a 128K tape, and you just say, give me a directory listing. It would show them to you, and then load that program in, and it would whiz through to the right place on the tape, locate it, read it out into the calculator. So very sophisticated, way more sophisticated than just pressing play on your cassette tape and listening to it as it loaded into your Spectrum or your ZX80 or 81 or whatever, that sort of thing. So very, but also quite expensive. So I bought one in 1984, I think, 3 or 4. Second-hand, and it cost me £150, which was an insane amount of money at the time. But anyway, HPIL is sort of the precursor to things like USB in a way. But what it meant is that this humble little calculator, as it came, when you plug that module in, you could connect it to 30 peripherals. So you could plug in a full-size printer, a plotter, a video interface, and plug it into your CRT TV or your screen. You could plug in an acoustic coupler modem. You remember those, when you had to lift up the phone and two massive cups and you plugged it in? You could get a modem on this calculator. The digital tape that I've shown you, floppy disks came in a bit later, and you could plug those in. Pretty much all of these devices, well, a lot of these devices could be battery powered. There were then interfaces for it. So you could plug in, you could convert from HPIL to RS232, GPIO, so you could have, standard input output type capability, HPIB, GPIB, IEEE 488. You could plug in multimeters, logic analyzers, and just a huge variety of equipment. You combine that with the time module. This machine could put itself to sleep, wake up, take a voltage measurement off a digital multimeter, write the results to a floppy disk or onto a tape, or call up on an acoustic modem and dial results in, and then shut itself down and go back to sleep for an hour before it did it again. This is quite a sophisticated little calculator, isn't it? It is crazy. Again, NASA liked this one. It got used on the space shuttle. There's lots of advertising that Hewlett-Packard brought out at the time, because again, 7 ounces of calculator, much smaller, much easier to carry around. They did do some subtle modifications. They made the beeper, which is extremely quiet. They made that a bit louder so that they could hear it over the air conditioning and all the noisy equipment in the space shuttle. And they covered it in Velcro so they could stick it on their uniform and their spacesuits and that sort of stuff. I'm glad to say that as a calcaholic, I'm not alone. And this particular one here that I've got here, before it became available on the iPhone 15, a chap in the Canary Islands built a rechargeable battery pack for it, which is connected by USB-C. so I now plug that into the same charger that I can plug my computer into to charge it up. There are people who, for fun, have replaced the CPU boards with ones with modern CPUs that emulate the old CPU and give you insane amounts of memory and speed and all sorts of stuff like that. There are, and this is what my desk at home sometimes looks like when I get around to doing proper calculating. So here's my digital multimeter connected into the calculator. There's a little box at the back there that a guy in France makes using modern components, and that allows the interface loop for USB-C into my brand new Mac, and my Mac can act as a plotter and a hard disk drive and all sorts of stuff like that. And then at the back there, you can see 2 floppy disk drives and the tape drive, and the calculator will run all of that very easily. You know, it's so remember, this is 1979. So if you wanted to do portable computing before the PC came out, you could carry around a Spectrum or a ZX80, 81, whatever. Then you'd need some mains, wouldn't you? Then you'd need a CRT TV and all of that sort of thing. I carried this around when I went to university. I could do all my programming assignments pretty much. I could test mathematics programs out on this, and I didn't have to cycle in and go and use the mainframe and that sort of stuff. So I thought this was a better solution, and it's you know, it's still being developed. We've got a guy who is developing a module a bit like this one that sort of expands all of the ROM space of the calculator, and he's making an updated version of that not only does that, but it adds the time module, the extended functions module, and all sorts of other things. So really maxes out the calculator. After the 41 came out, cheaper versions, non-expandable, there were 3 scientific programmables, the top model of which was the HP 15C. And its world first feature was that it added the ability to handle matrices and complex numbers. And that looks like one of these. So nice little calculator, beloved of many people, not expandable. You can't save the contents of the memory. It's got continuous memory, but if you accidentally blat the memory, you've had it. It was very valued by a lot of people who didn't need the expandability of the HP 41. Also in this series is the 16C, which is this one here, which is called the Computer Scientist. I love this one. I've only just recently got one of these. They were, the money had to be spent carefully when I was a student. So this one has, rather than A to E for programs, this one's got A to F. That gives you a bit of a clue. It can handle hexadecimal and binary and octal and denary, of course. You can set the word size on this calculator to be anything from pretending to be a 1-bit computer, not sure what use that would be, to a 64-bit computer. Now, I don't know about anybody else, but in 1981, 64-bit computers were, supercomputers, weren't they? I think I got what Apple described as the world's first desktop 64-bit computer in 2003. So 22 years after this thing came out. What is stunning about this is that there are, rather than having sine functions and cos functions and trig, log functions and all that sort of thing, is it has and an or, an XOR and not, rotates, shifts. It handles unsigned ones complement and two's complement numbers. So you can put in little algorithms in there that you might want to run on your 64-bit ARM processor. You could sort of debug them on this calculator, which is a bit insane, isn't it? Didn't sell as well as some of the other models. You can see that's a bit of a specialist model, can't you? This was the Voyager series. It was supposed to be something that lasted a few years. Came out in 1981. There was another model in this series, and so I'm going to briefly go. I'm not a big user of business calculators, but this is it. The HP 12C business calculator. You'll notice a subtle difference, certainly in the room, maybe not in the camera. The scientific ones had silver bezels, and the financial one has a gold bezel around the screen. Can you see? This literally is the gold standard. This calculator has been in production continuously since 1981. Now, find me another piece of electronics which has stayed the same. I've looked at other makes of calculators, Casio's, some of them. You see the model number has been around for 30 years, but the calculator itself is radically different. Yeah, this has remained the same. There are exams for how to use this. There are textbooks, there are courses. It literally is pretty much the de facto standard for financial calculations. It handles loans, mortgages, bonds, depreciation. It does stats, it does dates, and if all of that is not enough for solving your problem, it's programmable and it's got continuous memory. And it's still in production. It is absolutely insane. The interesting thing with this one is that maintaining something like that, you think about the silicon, the chip that is in there, the transistors are massive, yeah, compared to a modern machine. So Hewlett-Packard have had a few attempts at replacing it. And these are some of them. And George brought me one of these earlier on, didn't he? 10B. So 10Bs, different versions of that from different decades, 14s, 17s, 18s, 19s, 20, 30, and the platinum version. You'll notice no longer the gold standard, it's now the platinum version. Apparently users didn't like that one because they re-platformed the internals. They made it so that it supported not just reverse Polish notation, but algebraic or infix notation. But they made it, it used an ARM processor, and they made it too fast. And professionals weren't happy with this. So they brought out successive versions, which were slowed down, because they thought if it gives the answer too quickly, it can't be right. And they were used to the ARM models. So there may well be more, but that's some of the attempts at replacement. So remember, if you want the gold standard in financial calculators, still available in 2024, 2 years after it was introduced, 43 years after it was introduced, the 12C is still in production, which is mad, isn't it? It's absolutely crazy. Just as an aside, various companies went off programmable calculators in the 80s. I'm sure you've seen Casio. Sharp came out with the PC1211, was sold in the UK as a TRS-80 pocket computer with a 24, I think it was 24 character dot matrix display. And Casio and Sharp sort of went on, Sharp particularly went on to sort of dominate that market before we got things like PDAs. HP's second handheld computer, they did one before this, which was didn't sell especially well, was a little bit bigger and was focused at business people. So again, remember, sort of pre-laptop, and their advertising showed it in a businessman's suitcase with an acoustic coupler and maybe a printer and the mag tape drive. and it supported, I think it was VisiCalc spreadsheet. So it was targeted at the Road Warrior before the Road Warrior got a laptop. Yeah. This one, it has a very advanced version of BASIC, a bit like your old Sinclairs and stuff. A lot of, well, the key basic keywords are printed above some of the keys, so you could do Shift and the key, and you would get those. There was an assembler for this. There was a card reader. You can see, maybe you can't, but a slot up in the top corner. This one's not fitted with one, but it fitted in next to the display. The cards were really big compared to those other ones. So you could use those, and they were hand pulled. So you put it in and you pulled it through. It had software compatibility of a sort with the HP 41. So that HP were really interested in making sure that customers who'd invested money in software could run it on their successive generations of calculator. And my students will have heard of IEEE 754 because I teach them this. This is the floating point standard that modern machines use. This computer was the first one to, well, it actually implemented the draft version of it just before it was formalized. So it has some interesting additions to floating point systems that previously existed on the other calculators, which used binary coded decimal. This one uses a proper floating point standard, and it's got things like infinities and not a number and things like that are understood by the calculator. You could plug in one, a double module where you can plug in two HPIL loops. This would support extended addressing. So if you needed it to, this thing would talk to 960 HPIL devices. Why? I don't know, but anyway, it could. Possibly a bit over-engineered. By this time, we'd got a faster CPU and up to 0.5 meg of RAM that you could put in it. Then all sorts of things changed. You thought reverse Polish notation was a bit of a weird way of entering numbers and that sort of thing, doing calculations. Starting in 1986, HP produced this machine, actually, yeah, one that looked like this in a clamshell, and it used RPL, reverse Polish Lisp. It was hidden from users on the HP 18, which is business calculator, but it was made visible on this one, which was HP's first graphing calculator. Casio got in first with graphing calculator, but this was HP's first one. The clamshell design didn't terribly set the world alight, so we've got a more traditional one here. It combined Lisp and Forth, but the thing about this is the objects on the stack were now not just numbers, they were object-based. This is not object-oriented programming that this supports, but it's object-based programming. So you could put a string on the stack, a number on the stack, a matrix on the stack, graphics object, or whatever. And you could manipulate them. So you could put an equation on the stack and you could manipulate the equation. So no longer did your calculator need to calculate in numbers. So if you use things like MATLAB and things like that nowadays, computer algebra systems, where you can simplify formulae algebraically rather than numerically, this is where this first arrived on one of these HP calculators. We got more memory. You could have up to 4 meg, so a couple of cards in the back of these calculators that you could plug in. It had bidirectional infrared capability. It had got an RS2, well, a very specialized connector, but which gave you RS232 output. When I bought one of these and when I started work, we were using Vaxis. Do you remember those days? One of the first programs that I wrote for this one was a VT52 terminal emulator, so that I could walk up to the VAX with the serial cable plugged into this calculator, connect it up, reboot the VAX or whatever from that, rather than having to have a wheelie trolley with a VT220 massive terminal that you lugged around. So quite a nice little machine. The series were in production up to 2015. with the HP 50G. By that time, they'd added SD card, and the Saturn chip was getting so old by this time that we had to have an ARM emulator. Just as an aside, there's some of the olden machines running reverse Polish notation. So the 42, a non-expandable, slimmer version of the 41. The 35, which was the 35th anniversary of the original HP 35. Somebody got, a guy called Michael out in Switzerland, got a bit fed up that these machines were not available, and his favorite calculator was the 15C. Being a person who doesn't let things like obsolescence stand in his way, he started up Swiss Micros, and they build you a modern sort of interpretation of an HP calculator. So maybe software compatible with, you'll notice, a bigger display with an interface so that we can plug it into a PC. You can save the contents of RAM and all of that sort of stuff. So if you want to look, if you want a sort of more modern machine, and some of these have interesting characteristics. The 41 in the middle should run pretty much every piece of HP 41 software. Certainly everything I've thrown at it, including the machine code debugger that I wrote, runs on this. Sound functions work on it. So it's a stunningly good emulation. The 42 runs a 128-bit floating point library. So I think they claim that that is the world's most precise calculator at the moment. And then the current machine. So this is the HP Prime. It came out in 2023. You might just be able to see that it's got a color touchscreen display. You can draw graphs in 3D. I'm going to try and do this. I apologize if you're online, you might not be able to see this. Ooh. Let me try that again. So can the audience see that? Can you see this?
Yes, yes.
So you should be able to see a 3D graph on this screen, and I can you see it rotating in real time?
Yes.
Yeah. So you can see this is a very fast machine, isn't it? Essentially, you've got a mobile phone CPU in there. You've got a mobile phone battery in the back of it. It runs a Pascal-like language. You've got lots of apps that you can use. It's got an RPN mode, but it's very simple. It's clearly targeted at the education market. It's got an exam mode. There's no beeper, so it can't annoy people in the classroom. It's got it's not got an SD card slot. You can put it in exam mode. The teacher can you can put a little wireless dongle in the top, and the teacher can tell all the calculators in the classroom, disable some of the functionality. So you can disable the CAS mode, the algebraic mode. You can disable a graphing, whatever, programming, in order to meet appropriate exam standards. It's got micro USB. You can see we've gone from tiny amounts of memory. This thing's now got 256 meg of RAM, half a gig of flash. It's a very fast CPU. And I've been playing with this one. So let's see if I can get this to work. There we go. So I've got a load of I2I2C peripherals on this that I've connected. So I've got a temperature, pressure, humidity, gas resistance, so air quality, a luminosity sensor. I've got a digital to analog converter, and I've got a tilt sensor, all connected. And you might just be able to see. Can you see the graphs appearing in real time? So as I can use this for monitoring environmental conditions and stuff like that. So quite a nice machine. I've got a buddy in Texas. They're going to have a total eclipse in the summer, and what he's going to he's got this stuff, and using my software, he's going to monitor the solar eclipse look at how the pressure, the humidity, the temperature changes, look at the light levels as they change, which you could say, well, we can do that with a Raspberry Pi, can't you? But my ambition with this is that what we'll eventually do is the normal case, we've got a case for it that looks like that, and you'll plug it in, and then it's portable, it's nice and convenient, it's contained. So that brings us up to date. That's top of the range current calculator. The HP 15C, much to everybody's amazement, bear in mind that the 12C has been in production for 42 years. You'll notice that there is a certain family similarity between it and the 15C. And at the end of 2023, HP's licensee, because they don't make the calculators anymore, they've licensed it down, but they brought out the collector's edition of the 15C. So if you want to calculate like it's 1981, you can buy this. Yeah. So, and it comes with one of those things that you never see anymore. It's got a really thick manual and a leather case and all of that sort of stuff. So there we go. So a bit of a history of innovation. Note the disclaimer, other manufacturers, other makes of calculator are available, but and these are mine that I think I've got this right. The first Pocket Scientific, the first Pocket Programmable, the first smartish, the first with solve and integrate, the first with wide peripheral support, so the 41 there, the first with symbolic algebra, the 48 I didn't mention, but you can, every object you can tag units on there, so you can put in 30 meters per second, and then you can say, convert that into miles per hour. So you can do calculations with units, and then you can say, right now, give me in SI units, and it will convert it all for you into the right units and do simplifications on those. So the first with unit management, the first, I think, with exam mode and class-wide interactivity, and I believe the longest produced calculator in terms of the 12C in its original form. I'll leave you with this, some further information and reading. The club that I'm in, hpcc.org, we've been going for 40 years, 41 years, 42 years now. There is lots of information at the Museum of HP Calculators. If you're a 41 person, hp41.org has got an archive of pretty much all the software. The later RPL calculators, hpcalc.org has got all of that. To celebrate 40 years of our club, I did co-edit a book, which unfortunately we've just sold out of. So we're awaiting the next print run to come through. But if you're interested in this generally, there is an excellent book which you can buy off Amazon and other good booksellers called Empire of the Sum by Keith Houston. It's got there's a paragraph, a chapter or two on HP calculators, but lots of others, Curtis, slide rules, mechanical calculators, and all sorts of variations on the theme. So that's great. He's done a huge amount of research. His references are excellent in the back of that book. And as we're in East Anglia, I will put in a plug for this. I've been working with the curator at the Francis Hookham collection at the Whipple Museum of the History of Science and History of Science at Cambridge University. A quick picture, that's the outside of it. It's a very elegant building, as you might imagine. It's got astrolabes, it's got mechanical calculators, it's got telescopes, it's got all sorts of things. So something that probably appeal to IET members if you get a chance to go there. Up in the top right-hand corner, I saw those in the cabinet. I thought they were interesting. They're quite difficult to see, but it's apples. They're called Archimedes apples, and they're for teaching fractions. They are immaculately well-produced things from, I think, the 1800s. Oh, 1930s, sorry, 1930. So you've got these little apples that fall about into segments for teaching fractions. Beautiful little objects. And they're calculated, some of them are on show. These were donated by Francis Hookham, who was an architect in Cambridge who used an HP 41. And he realized at the time that calculators had sort of suddenly appeared, and the technology, you could see from those dates, it was changing incredibly rapidly. And nowadays, where are calculators? Who uses a calculator in their day-to-day life? School kids, that's about it, isn't it? You know, so you might use the calculator on your phone occasionally, but they've sort of gone.
I tried to use one recently to calculate capacitive reactance, and I couldn't work out how to use it.
Yeah, so yeah. Francis Hookham donated his collection of 400 odd calculators to the Whipple Museum. Boris Johnson, interestingly, back in the day before being Prime Minister, he wrote a rather odd article in the Telegraph that said, "This is a bit strange. Are we just going to put all of our old junk into a museum because, you know, it's no longer made anymore?" But I think Francis Hookham did the right thing, but I'm biased. There are lots of calculators there in Cambridge. And with that, I'll finish.
Thank you very much, Mark. Thank you for a great talk there, Mark. I'd like to move into Q&A now. So we'll take Q&A for questions from the atrium here, University of Suffolk, and also online. So if you're online and you'd like to ask a question, then please use the Q&A facility. I see there are one or two questions that have come up already. So we'll take one or two from the audience first, and then online. So yeah. Ian, over to you.
So from the audience first.
Yes. They need power.
Yeah.
Do they use sort of the plug-in sort of rechargeable AA batteries, or are they rechargeable batteries in there? What sort of batteries?
Yeah, they vary. So some of them use C-cell NiCads inside preformed frames. So the big one, for example, these ones use standard coin cells, that sort of thing. If any top tip for anybody who's out there, if you use any of the 20 series, if you're tempted to go, you've got one in the cupboard, or your dad's got one in the cupboard, or your mum's got one in the cupboard, and you go and pull it out, for goodness sake, don't plug it in, because the battery is an integral part of the voltage control circuit. And if you've got the mains adapter and you plug it into the battery and the battery's dead, you'll blow the calculator. There's a huge number of them out there that are dead. You can rebuild the battery packs quite easily. They come apart. You can get 3D printed ones, which I've got a number of those. The coin cell ones, the original 12Cs were incredibly efficient, battery efficient. And top tip on those as well is that please don't use alkaline coin cells. You want to look for silver oxide, because as far as I know, they don't leak. And I've known people who are running their original Voyager series calculators on the original set of batteries after 20 years without any trouble. So, yeah.
We've got a couple of questions from Alexander Wood, which I think you'll be able to answer quite easily, Mark. Unchanged business calculator that's still being sold. How many do they sell?
Yeah, I think that's what they call a closely guarded secret, but right. Millions is the
really?
answer. Yeah,
what, even now.
Now? Oh, I don't know about now. I know their licensee was saying that they just before Christmas, I think they shipped 70,000 of them to Brazil. So, there's a lot of demand out there for them. So, yeah.
Okay. And the follow-up from him is, how many members are there in the HPCC?
Oh, good question. I think about 120 calcaholics.
All right. Is there one from the audience? Another one? Yes.
The latest version, the Prime version.
Yeah.
How much is that today? How does that compare in the way that the price has gone?
The primes, I think, if you look up somebody like, Plug, Oxford Educational Supply, somebody like that, I think they're about 110-ish, mate. I can't remember if that's plus VAT or not. I think about £120, something along those lines, which is comparable to top-end Casio and Texas Instruments calculators. So about that sort of figure. So not a impulse buy for the vast majority of students. Certainly, it's an expensive item. The 15C relaunch, that's about the same price actually, which is interesting because it's sort of maybe swiped the market from Swiss Micro's 15C line, because I think they were charging about 180, and then Hewlett Packard's licensee then came out and brought the original item for a fraction of the price. Yeah, so yeah, but about £120, I think. Yeah.
Thanks, Mark. Again, Alexander, who's obviously
sorry,
keen. He's someone like you, Mark, I think, on calculators. He's asked, as HP did many things first, did other companies copy them, and how did other companies' calculators compare in terms of functionality, extendability, and popularity?
Well, I went to a Calcoholics conference in Florida last year, where I met up with all the American gang. And over in the States, the predominant calculator are Texas Instruments, whereas in the UK, it's Casio, isn't it? And if you look at a shop that, if you can find a Ryman's or a WH Smith's, they tend to have just a rack full of Casio calculators in this country. Casio, I think, did some lovely calculators. At the time, some of them were a lot faster than some of the HPs. There was the FX602, which had alphanumerics, and it was a dot matrix display. The 41 is a starburst. It's a 16-segment starburst, so it can't show every character. Particularly, it can't show all of the lowercase characters. The Casio did have this nice display, but it couldn't do text manipulation. The text was there primarily as a prompt. Sharp went off down the route of the pocket computer. I briefly dabbled. I had a Casio version. It wasn't as expandable. It looked like it was a stage on from the 41, but I sold the Casio and bought a 41 because I wanted the expandability and the flexibility. Casio did bring out the world's first graphing calculator, so the 7000G, I think it was theirs. And there are, if you look on at HPCC's site, the Whipple Museum produced a book called Multiply, a catalogue called Multiply, and in there are some amazing machines. One of them is what we refer to as the calculator, and I'm not speaking Australian there, but Casio brought out a calculator with a cigarette lighter on the top, and their advertising explained that the two functioned independently, so were always ready for use when you needed them. HP didn't follow suit and produce a calculator, oddly, but yeah, there are some weird and wonderful machines out there.
Do we have another?
Yeah. The
Chris.
continuous memory, what sort of technology does that use? Is it battery backed up RAM or EEPROM or something like that?
It's CMOS, low power, I think.
EEPROM.
Not EEPROM. No.
There's no retention cell. It's just.
Yeah, you get a few. Oh well, it's maintained off the battery. You can change the batteries so long as you do it within.
There's like a capacitor to hold it for.
10 minutes or whatever, or something like that, or a bit long. Yeah, CMOS RAM. Yeah, I think that's probably all of them. The newer ones, flash and stuff like that. So yeah.
There's another question from the audience.
You mentioned Texas Instruments.
Yes.
Mainly the calculator I had when I was at college, and my children had them as well.
Yeah.
But I always had problems with the reliability. In fact, there used to be a joke called the Texas Instrument disease.
Yes.
It's a keyboard bounce. So you put one in, it goes 1 1 1 1 1. And I don't know whether it was their circuitry, what they did, but how do these keyboards last over the years?
And HP were not immune. Certain of their calculators had this problem. The vast majority of these, all of these that I've got on the desk, they all work. They've all got gold contacts on the keys. So the HP 34 that I've got, they experimented with a cheaper production technique where they weren't soldered ribbon cables between the boards and display and the keyboard and that sort of thing, and it was sort of a push fit type thing, and that is quite unreliable. When it's been warmed up and cooled down a bit, you turn it on and sometimes it doesn't work, and you literally go with the case and it starts working. But the TIs, yeah, I recently inherited a number of TIs. I put new batteries in them, turned them on, every screen was black. Just wouldn't work. The majority of the HPs, you paid a lot. These were for engineers. These generally weren't students. These were not the bottom end of the market. If you look at TI's answer to the HP 35, I can't remember the model number, but they basically got the same functionality down to $25 as opposed to $400. Yeah, and they did it by because they made the chips. They put everything on one circuit board, and there was something like 6 screws in the construction. Oh no, did they get rid of the screws? I think, or something like that. It was basically slap it together and it worked. But yeah, unreliability, I think, plagues a number of models here.
Well, we can take a question from the online community. Graham Panton asks, how do these compare with what you can now do on a smartphone, Rich?
Yeah, well, for one thing, you can run emulators of nearly all of these machines on your smartphone, which I do as well. So I'm never without one. Essentially, what's in a Prime is a smartphone processor and a smartphone. It's actually got a Samsung smartphone battery in the back of it. They are optimized for doing a job. The battery life is hopefully significantly longer than your smartphone. In terms of capability, though this has got a touch screen, even though you can pinch and punch and zoom in and out graphs on the screen, something that I didn't show you, you can put it in graph mode. You get a blank screen, and you can say sketch, and you could rub your finger along the screen, and it will work out what the formula is for that equation that you've just drawn. Yeah, you could do all of those sorts of things in things like MATLAB on a laptop, but I think you would struggle to run MATLAB on a smartphone on the display, where you've got no physical keys like you have on here, and where the touch screen is is quite small.
Right. There's one more here, which I think a few people would like the same answer, really. Is so without the equal sign in the calculators, how did they get the answers, or did it just automatically appear?
No. It was that whole business about. So if you want to add 1 plus 2 together, you do 1, enter 2, and when you press plus, the plus gives you the answer. Yeah. So you see the answer immediately, and you've got a stack of answers, and you can recall the last X value that was put in. Yeah.
Any questions more from the audience? No?
So Mark, how many calculators have you got?
Yeah, quite a lot. I think this is about a third, maybe a quarter of the ones that I have. I'm not a complete calcaholic. I only, before COVID, COVID has a lot to answer for, doesn't it? I think I had 6 of these. A friend of mine in Scotland who used to work for HP, he spoke to his buddies and said, anybody got any calculators kicking about in the drawer? I acquired a few, then I acquired a few off eBay, and yeah, so I've got quite a lot now. I try to make them all work. I try to demonstrate them to people. So, but I know there are serious collectors who, for example, have had, at least 10 versions of this. With slightly different keyboards, slightly different displays. There are maybe, I don't know, 20 versions of that, that are subtly different labels on the back. The 35, there was a bug in one of the original commands, one of the log functions, I think it was, and HP said, we can't have this, we'll have them all back and replace them. Not surprisingly, there are collectors out there who value the ones that contain the bug that give you the wrong answer. So I know people who've got hundreds, possibly thousands. Yeah. So I'm a beginner.
There's another question online from Alexander Wood. I can't remember you saying this actually, but when you mentioned the solution books, I think the packs, you mentioned one for astrology. Did they really make one for astrology rather than astronomy?
Both.
Both?
Yes.
Okay.
Yes. I believe I got that right. Yeah, that there was an astrology one as well as an astronomy one. Yeah. Crazy.
Right. I think we're out of questions online. So if we're out of questions in the audience as well, I think probably it's time to finish, and actually on time, Kevin.
Very good. So thank you once again, Mark, for taking the questions and also for a very, very interesting talk. So I'd just like to express our thanks once again. So just to wrap up, I'd just like to do a little plug for our IET local network. We've got a very extensive program for 2024. It's work in progress, but the first two talks we're nearing nailing those. So the first one will be New Space, the future of satellite communications, and that's going to be delivered by Professor Andy Sutton from BT. That's sometime in April. I've got to nail down the date and also the format, but knowing Andy, he'll probably deliver it as a face-to-face event, and we'll have it as a hybrid event. The other one that we've managed to progress is Quantum. So Quantum, Game Changer or Niche, and that will be delivered by Professor Andrew Lord from BT, and that'll be on the 16th of May, 7 o'clock, and that'll be a hybrid event. So those are two of the talks which are shaping up. There are others in the program. We're trying to sort of aim towards one talk every month to 2 months. So watch this space. The IET EngX community website will contain all the details for our talks. So if you're interested in those talks and the program, then please look at the website.